Example 7.1 Specific energy diagram. Okay. Water flow up on the 0.15 meter tall lamps, that is lamp set equal to 0.15 in a constant width of rectangular channel at a rate q, small q is cubic 0.56 cubic square meter per second. In the below figure, the upstream depth is the 0.7 and viscous effect are negligible. Determine the elevation of the water surface downstream of the lamp or y through passes through. Okay, so this is profile of the lamp. At point 1 is y1. y1 is 0.7 and this is v1. And what is the z2 plus the y2? Okay. So next we use the conservation of energy. We assume the head loss is 0 and we start with the boundary equation between point 1 and point 2, and next we find the number for each parameter. For y1 is equal to 0.7 meter and z1 is 0, z2 is 0.15, and for v1 is equal to q divided by y1. Small q is the discharge per unit bit, so it's 0.56 divided by, so that is 0.8 meter per second. And next we substitute number in equation 1 plus 0.8 Okay, so we arrange this equation to get y2 plus v2 squared over 19.6. That is the equation 2. So we assume that q is constant and v1 y1 is equal to v2 y2 equal to 0.56. So we can substitute v2 is equal to 0.56 divided by y2 in equation 2. Okay, so we got 0.158 equal to y2 plus power 2 1 over 19.6. Okay, we can rearrange this again to multiply y2 square on every term. So we got the power 3 function. So we can solve this solution to get 3 solutions. And the third solution is negative number. Okay. So we can prove that water level is equal to y2 plus z2. So there is a two choice, is the 0.53 plus 0.15 is equal to there's another choice. So we have two solutions. So we don't know which one is correct answer. So from equation 3, we can write the curve. Okay. Or we can write this from equation 3, or we can write from this equation. Okay, we can write the equation between the e and y. Okay. And based on this, we can find what is the yc. For rectangle, so yc about 0.317. So that is yc 0.317. Okay. The other one is e minimum is equal to 3/2 of yc. So we got about 0.476 meter. So that is 0.476 is e minimum. Okay, this can write e minimum here at this point. Okay. And if we write the equation between at point 1 and point 2, we can, that is the E1 is equal to E2 plus delta z. Okay. And for E1, energy at section 1 is equal to 0.7 plus the velocity square over 2g is equal to 0.73 meter. Okay, and we plot that is this point is 0.73 meter. Okay, and from this we can read that the depth is 0.7. Okay, for E is 0.73, the depth is 0.37. For E is 0.73, depth is 0.7. Okay, and we can estimate what is the E2 is equal to E1 subtract 1.15. So we got about 0.58 meter. So that is the location, that is the 0.15. Okay, it's the E for second point. Okay, and from this point we can read from this curve to find what is the depth. We can read the depth is about 0.53. Okay, read from the curve. So we can come up with the conclusion that y2 plus z2 is equal to 0.68 meter. So if we compare to the point 1, water level drop is equal to 0.68 plus the 0.15 subtract 0.7, so we got about, okay, it's a water drop compared to the first section.